All right, picking up on number 56. So I've got 12y squared minus 3y, and I want to factor it completely. So my GCF is 3y squared. So I'm going to factor out my 3y squared. That's going to leave me with 4 minus y. If you want to put the y's first, then you could factor out a negative 3y squared, and then that would leave you with y minus 4. Okay, 4x squared minus 9, that is a difference of 2 squares. So the square root of this is 2x, square root of this would be 3, so I get 2x plus 3, 2x minus 3. So do I keep going and solve for x? No. A couple reasons. First of all, it says factor. It does not say solve. Second of all, you do not have an equation. You have an expression, so don't make stuff up that's not actually there. All right, so then I need to factor this one here. Okay, so I'm not exactly sure how you learned to factor with a not being 1. Back in my day, we learned the guess and check method, but there is this method that probably has a name. Not 100% sure that it's exactly like what Ms. McWhorter would have done, because there's a couple versions of this, and there's something that's minor that's different. But here's my way, which isn't the way that you have to do it, but I'm going to multiply, since there's no GCF, you check for that first. I'm going to multiply 6 times 3. That gives me a negative 18. So I'm going to look for the factors of negative 18 that would give me this positive 7. So factors of 18 would be like 1 and 18. We got 2 and 9. We got 3 and 6. So since it's negative, one of these two has to be negative. So basically I want them to subtract. Well, 9 minus 2 is 7, so I'm good there. So I'm going to set these up like this. So this is x and x. And this would have to be, to get my 7, this is going to be a positive 9 and a negative 2. Now, I can't leave it like that because clearly that is not going to multiply back to give me that. So you take this 6. The 6 is still important here. So this guy right here, you're going to divide both of these by 6. You put it over 6, and then you reduce them. Okay? So when you reduce 9 over 6, that's going to reduce to 3/2, right? So that 3, that numerator stays here, and that 2 comes out in front of the x. So you got 2x plus 3. Then you reduce this, that's going to give you negative 1/3. So that negative 1 stays there. The 3 that would be the denominator comes out front, and you get 3x minus 1. Pretty sure the other way to do that would be to put that actually 6 in both terms. I mean, I've seen it done different ways and different teachers teach it differently, but if it helps you to go ahead and reduce this first so you can really see it, that's 3/2 and the 3 stays there, the 2 comes back up in here. But then you can always check yourself if you're unsure. 2x times 3x, 6x squared, then you've got 9x and a negative 2x, that gives you your 7, and then your negative 3. Oops. All right. Number 59. So the first thing you always want to check for is your GCF. So my GCF here is 2x, so I'm going to factor out a 2x. That's going to leave me with 25x squared minus 1. That is your difference of 2 squares, so 2x times 5x plus 1 times 5x minus 1. So then here, to be able to factor this one, this is your perfect square trinomial because 25, square root of 25 is 5. This is square root of y squared is y, and so this is 2 times 5 times y, or negative 2 times 5 times y. So the square root of this right here is 5x. Square root of this is y minus, and it's squared. Okay, 61. I'm going to factor out the GCF, which is 5x. So I get 5x times 9x squared minus 6x plus 1. So same thing, same kind of pattern happens here. The square root of 9x is 3x. and the square root of 1 is 1. So if the square root of, this is a squared, so this would be 3. So negative 2 times a times b here, then I get the negative 6. So I get 5x. Square root of this is 3x minus the square root of this is 1. There's your perfect square. All right, so do I have a GCF to factor out here? No, I do not. Can I factor by grouping? Yes, I think I can. So I'm going to look at these two together here and these two together here. So with these two, I can factor out a 3x. That leaves me with x squared minus 5 plus I can factor, my GCF of these two is 2y, so that's 2y times x squared minus 5. And oh look, now I have another GCF. So I can take that x squared minus 5 out front, and that leaves me with 3, oh, I left off my x, dang it. 3x plus 2y. Sorry about that. Yeah, my GCF here was 3x, and I didn't write my x. But there you go. I've factored that all the way. Can't factor anything else, so I'm good. Okay, so here's another special case. I've got a sum of 2 cubes. Cube root of 125 is 5. Cube root of x cubed is x. Plus cube root of 27 is 3. Cube root of y to the 6th is y squared. So there's that. Then what I'm left with is this squared, so 5x squared minus 2 multiplied together, so 15xy squared plus this part squared, which is 9y to the 4th. All right, state the transformations that are occurring to the parent function for each of the following. All right, so since this is negative, we have a reflection over x-axis. Then the 2 multiplied in here also gives me a horizontal compression. Oh, I don't know how to spell compression. Apparently. And now I can't undo. Oh, goodness. Not responding. Story of my life. Alright. Why don't I do this? Period. There you go. That way I don't have to worry about it. Okay, so then on this one here, we have a reflection over the y-axis and a translation 3 down. All right, so let's write some of that. We're going to translate 3 units down. And reflect in y-axis. And then that 4 gives us a vertical stretch. Okay. Then here, since this is x minus 1 inside of here, we translate 1 unit right, and that 0.5 there makes that a vertical compression. All right. So we're going to graph the function and plot at least 3 points. So square root that's opening down but translated up 2. So there's one critical point there. And then if I plug in a 1, square root of 1 is 1, so that's negative 1 plus 2, so I'm at 1, 1. And then I can do 4, square root of 4 is 2, so negative 2 plus 2 is 0. And here's my curve. Okay. So f of x equals 2 square root of x plus 2. That means I'm going to translate it 2 to the left. And then this is going to get stretched, so I'm going to do let's put in 2. So 2 plus 2 is 4, so that gives me a 2, 4 right there. Oh, what did it do? That doesn't make any sense. What I meant to do, I was treating that like 0, 0. Okay, so if I plug in, if x actually equals 2, which is what my intention was, then it's 4. There we go. Okay, so now I'm going to plug in negative 1. And if x is negative 1, so negative 1 plus 2 is 1. Square root of 1 is 1. So 2 times 1 is 2. So negative 1 up here, 2. Looks something like this. All right. So graph each of the following exponential and logarithmic functions. Plot at least 3 points. All right, so if f of x equals 0.5 to the x minus 1 power, okay, so 0.5 is basically 1/2. If you think about it that way, then when I plug in 0, that's going to give me 1/2 to the negative 1 power. So when x is 0, y is 2. When I plug in 1, that's going to give me 0. Anything 0 to the 0 power is 0. I'm sorry, anything to the 0 power is 1. Right. And then when I plug in 2, that's going to give me 0.5 to the first power, which is 1/2 right there. If I plug in negative 1, then that's going to give me 1/2 to the negative 2 power, which means that's going to be 4. Go right there. And that gives me a pretty good curve. Like so. All right, so 3 to the x power minus 2. All right, so that one, just kind of plug numbers in. Let's look at this from a transformation aspect. If I have 3 to the x power, so any of our exponentials, when x is 0, y is 1, right? So this is where I should be if it was just 3 to the x power. But I've got that minus 2, so that's going to translate it 2 units down, so I end up right here. So what you have to remember is that when you're here, if I was here and I didn't translate down 2, then it's going to come down and touch the x-axis, but that also gets translated down. So here's basically where I have to make sure this is my horizontal asymptote, right? So when x is 1, then that's 3 to the first power, which is 3 minus 2. So this is going to be 1, 1 here. When that's 2, then that's 9 minus 2, which is 7. 2, 3, 4, 5, 6. Ooh, can't really fit that. So let's look back here. What if it was negative 1? You've got negative 1. That's going to give me a 1/3 minus 2, which is going to be negative 1 and 2/3, so somewhere right about there. So look like this. Oh, curvy though. It's not very good. All right. I'm going to have to stop here today because I have to go home. I will try my best to finish the rest tomorrow.